Hi guys. So today what we're going to do is we're going to start looking at how to draw some angles, and we're going to learn just some new vocabulary about some different things we can do with angles. For today we're going to work with everything in degrees, and then tomorrow we're going to learn what a radian is, which is a different way to measure an angle. So to start off, we're just going to talk about how to draw an angle. So in order to draw an angle, you really need three components. The first part is what's referred to as the initial side, which is this bottom part right here. Then every other angle also will have a terminal side, which is where the angle ends. And the terminal side, kind of think like an airplane terminal. So it's like where you end your flight at the terminal. And then also what we need to add is we need to have an arrow that goes from the initial side to the terminal side. And what that arrow does is it shows us is this angle positive or negative, and how big that angle is. So let's say, for example, this was a 45-degree angle. I would just start from my initial side and just draw a little arrow there to my terminal side. Keep it pretty simple. What we're also going to have is we're going to look at angles in our 4 quadrants like you learned about back in your previous math courses. So if you guys remember how to number your quadrants, number 1 is over there in the top right. That's when your x and y values are both positive. Then we move in that C pattern to where the next one would be 2, then 3, and then here in the bottom right I would have 4. So those are my 4 quadrants. Now what we're going to do is we're going to label these border angles on here because it's going to make it easier for us to draw some of the other angles that are going to come up. So we're going to start with 0 degrees, and 0 degrees is right here on this line. That is always where we're going to draw the initial side of every angle that we draw. So the initial side will always be right here on 0. Now if I were to do a full circle, let's say I start here and I go all the way around in a circle, we know a full circle is 360 degrees. So that's also 360 there. This line up here in the top, that's going to be our 90 degrees because it makes that right angle. Then if I had a straight line all the way here on the opposite side, we know that that's 180 degrees because 180 degrees is a straight line. And then if we did a little bit of math, we could figure out what this bottom line is going to be, and that's 270. So knowing what these 4 angles are, it's going to help us to draw some other angles in other quadrants. So let's do a couple examples of just drawing some angles. So let's start with 137 degrees. So if we're not sure where to draw it, it helps to know again where those border lines are that we just figured out. I know that this line here is 90, and I know that this line is 180. And I know 137 is in between those two numbers. So what I do is I draw my initial side at 0, I draw my terminal side in between 180 and 90, and then I go from 0 to 137, and there's my angle. Now if I have a negative angle, I'm basically going in the opposite direction. So what that means is I'm still going to start at 0 with my terminal or my initial side. But instead of going 60 degrees this way, I'm going to go 60 degrees in the opposite direction. So if I go backwards, I know this, instead of being 270, would actually be a negative 90. So a negative 60 would land here in the 4th quadrant. So when I have a negative angle, that arrow goes the opposite direction. Now let's say I have something like 500. Okay, I know a full circle is 360 degrees, so it's hard to see what quadrant this is going to fall in because it's more than a full circle. So what we can do is we can subtract 360 to get a better picture of where this angle is actually going to end. And if I subtract 360, that shows me I'm actually drawing a 140 degree angle. So I'm going to go ahead and draw that line. We know 140 would end in the 2nd quadrant. But my arrow here is what's going to show that this angle is different than the 137 degree angle. If I were to just draw the arrow like I did for the 137, I wouldn't be able to tell the difference. So since I went a full circle before I ended at 140, I'm going to show that in my arrow. I'm going to go around a full circle and then end at that point. Alright, so let's do one last example. If you want to pause the video and try this one on your own, that might be a good idea. But we're going to do negative 223. So again, if I start at 0, I'm going to go backwards in the opposite direction, which means I would go to negative 90, then negative 180, then negative 270. So I know negative 223 is again going to fall there in that second quadrant. But my arrow is going to go backwards. So now we're going to look at a word that we've actually already used here without even knowing it. This new vocab word is called coterminal. So coterminal angles are angles who share a terminal side. Okay, so they share a terminal side. So they share, and terminal. Okay, and by sharing the terminal side, that really means they end in the same place. Okay. So what's going to make them different is our arrow. So for example, when we just did that last question with 500 degrees, well, 500 degrees and 140 degrees, they both ended in the same place. They were both coterminal angles. 0 and 360, that was another example. They both ended on that line, so those were both coterminal angles. They shared the same terminal side, and they ended in the same place. So what we're going to do is we're going to start off with a 20-degree angle, which should be here in my first quadrant. And I'm going to find two more coterminal angles that end there. So I'm still going to have my initial at 0, but basically it's going to have a different arrow. So one way I could find a terminal angle is by going backwards. So if I were to go backwards, that angle would actually be 340 degrees in the negative direction. So a negative 340. Another way I could get a coterminal angle, if I draw this, and I go in the positive direction, but I make a full circle and then end there. It's also coterminal, but it's going to be a different measurement. So what I would do here is I would take my 20 degrees, and I would add 360 to give me 380 degrees. Now when it comes to coterminal angles, there's actually an infinite number of possibilities here. I can add or subtract 360 as many times as I want to, and that's the easiest way to find a coterminal angle. So in order to find a coterminal angle, what I need to do is I add or subtract 360 as many times as I want. So what I'm going to put there is an n, which again just means any number of times, but it needs to be a whole number. We can't say like 0.5 times because that's not going to be a real coterminal angle then. So I add or subtract 360 as many times as I want to, and I can get a coterminal angle. Alright, so the last little piece of vocab we're going to look at with angles is called a reference angle. And a reference angle is going to be really important for what we do later in this week when we start finding exact values. In order for something to be a reference angle, three things have to be true. It needs to be acute, or 90 degrees. It's made with the terminal side of the angle and the x-axis. And this is probably the most important piece. It has to be made with the x-axis. So the horizontal line, and that's the most important part of this. And then also it's always positive. So this first one here should hopefully be pretty simple. I'm going to go ahead and draw my picture because that's going to help us find these much easier. So I'm going to draw a 50-degree angle. And I'm just going to look. Is that angle acute? Yes. Is it formed by the terminal side and the x-axis? That's true. And it's positive. So in this case, my reference angle for 50 degrees is actually 50 degrees. And that's going to be true for any acute angle in the first quadrant. But let's look at a 130-degree angle. So we need to figure out first, in which quadrant will the terminal side of this angle fall? So I know my initial side's always at 0, here's 90, and here's 180. So that means the terminal side of this angle is going to fall in quadrant 2. And I know that this part right here is 130 degrees. The reference angle, though, again, is going to be the part made by the terminal side and the x-axis. So I'm looking for how many degrees are in this little piece right here. And in order to figure that out, that's why the picture is really helpful. If I know it's 180 degrees to that straight line, I can figure out that little blue colored in piece is just 180 minus 130, which is 50 degrees. So my reference angle here is 50 degrees. Alright, so we're going to do a couple more examples with reference angles. So let's take a negative 30-degree angle. So a negative 30-degree angle, I'm going to go backwards 30 degrees, which means the terminal side is going to fall in quadrant 4. So that is a negative 30-degree angle. Well, the reference angle, again, it's formed by the x-axis and the terminal side, so it's this part right here. So that angle, it is acute, and it's formed by the x-axis and the terminal side. The only problem is that it can't be negative. So this one's also kind of simple. It's going to be 30 degrees. Because again, I don't care about measuring it in terms of the direction. I just want to know how much is that little in-between piece right there. Okay, so the last one, to draw our picture for 705 degrees, it's going to be very helpful for us to go ahead and find a coterminal angle. So let's find a coterminal angle, because then it'll be between 0 and 360 and be easier to work with. So if I take 705 degrees and I subtract 360, because that's one way to find a coterminal angle, then I'm going to get 345 degrees. And 345 degrees is going to fall between 270 and 360, which means the terminal side of this angle is going to be in quadrant 4. So that angle would look like this. But to find my reference angle, I want the piece in between the x-axis and the terminal side. So I want this piece right here. So in order to find what that value is, I know it's 345 to this yellow line. It's 360 to make the full circle. So that means that blue shaded in piece has to be 360 minus 345, which gives me a reference angle of 15 degrees. Alright, so now that we know that angles can fall in any of those 4 quadrants, we're going to reevaluate some of those trig functions that we looked at by using our reference angles. Okay, so what this question says to do, it says find the exact value of the 6 trig functions of an angle theta whose terminal side passes through the point -4, 3. And the directions on here, it's kind of wordy, but it's actually pretty simple when we draw our picture. So what I'm going to do to start is I'm going to go ahead and plot the point -4, 3. And what the question tells us, it wants us to find the trig functions for theta whose terminal side passes through that point. So what I'm going to do is I'm going to draw the terminal side of an angle. And in order to find these trig functions, we're going to use the reference angle. So in order to turn this into a reference triangle, what I do is I take that point and I connect that point to the x-axis, which means that the theta value is going to fall in between the terminal side and the x-axis. So whatever angle would have been right there, those trig values are going to be equivalent to that theta that's the reference angle. That's why reference angles are important, because they'll be equal values. The only things that'll change between them are some of the positives and negatives. So if I were to go ahead and try and solve this question now, it wants me to find the sine, cosine, tangent, secant, cosecant, and cotangent for theta based on this picture. So looking at this picture, I can go ahead and plug in those points. I know the top part of this triangle here, because I went up a distance of 3, that value of my triangle is 3. I know I've gone side to side 4, but because this is on our xy axis here, I need to make it a -4 because I've moved in the negative direction. Then I need to figure out my hypotenuse. Your hypotenuse on these pictures will always be positive, because if I were to do Pythagorean theorem here, if I did 3 squared plus -4 squared, it doesn't matter that -4 is a negative value, because any negative squared still gives me a positive. So I still get 5. Your hypotenuse in these pictures will always be positive. So now that I have my picture drawn, it's the exact same thing we were doing back when we did trig. The only small difference here is that now you have the potential to have a negative depending on which quadrant you're in. So now all I need to do is list those functions. So for example, the sine of theta is the opposite over hypotenuse, which on my picture is 3/5. The cosecant of theta is the reciprocal of that, which is 5/3. The cosine of theta is the adjacent over the hypotenuse, which is now negative. That's why when you guys were doing some of those calculator calculations on your last assignment, you got some negative values, and a lot of you were kind of confused why that happened. It's a matter of that angle falling in a different quadrant. So there are certain quadrants, we'll notice some trends later on, there are certain quadrants where cosine or sine can be negative. So then if I wanted secant, I would just flip that ratio, hypotenuse over adjacent. And then finally tangent, opposite over adjacent would be a negative 3 over 4, which means that cotangent would be a negative 4 over 3. And one thing to notice there, guys, with the negative, it doesn't matter where on that fraction I put the negative. If there is one negative on the whole fraction, it makes the whole fraction negative. So, for example, a negative 3 over 4 is equivalent to a negative 3 over 4, where the negative is completely on the outside. And that's the same thing as 3 over negative 4. So if there's one negative, the whole fraction is negative. It doesn't matter where it is. I can put it with the top number, I can put it in the middle of the fraction, or I can put it with the bottom number. It'll all end up being the same thing. Alright, so that's all we have today for angle measures. Tomorrow we're going to start to look at radians, which is just a new way to learn how to graph.